Whoa, that's... Oh, I'm not logged onto mine here. That's nonsense. All right, welcome back, everybody. We're in biology. All right, welcome back, guys. We are in bio. It is Wednesday, September 11th. Study hall today, Wednesday, is, I want it to be Wolford, but I don't think that's what it is. I like the alliteration for Wednesdays with Wolford. But it's actually with Mr. Chapman. Cool. Next to Wolford. Wolford adjacent. Okay. Cool. So, today we get to continue on. We are going to be talking about 2.2 today, and that's where we're going to start. And in 2.2, we are going to be looking specifically at energy. So that comes in a variety of different flavors and from different sources. We're going to be looking at how that energy flows throughout an ecosystem. So our main header, or our overall topic, is energy flow in an ecosystem, or in ecosystems. Now, with the vocab stuff, if you went first, it is entirely up to you. I will redefine words. I'm going to do it a little bit more casually than maybe I normally do because you already have all those definitions. If you need to write them down again to get them to stick, I'm cool with it. But if you just want to write the word and do like some small examples, I'm not going to require you to do everything that I write down, as always. So, energy flow within this. Now, when we talk about energy in an ecosystem, there's probably a variety of things that come to mind for you. First thought when you hear the word energy, what's the picture in your head? Electric energy. Okay, deal. Do we use electricity?
Yes.
We do. What if there's like no lights and stuff and I'm in the middle of the forest or the middle of the tundra and I don't have a phone? Do I still use electricity?
Yeah, your eyes. Right?
I use electricity all the time. Remember, we're big meat computers. Like, that's crazy, but we are. So we're going to look at energy in an ecosystem. My first thought, interestingly enough, when I hear the word energy, does not go to necessarily electricity. I think of just a ball falling. Like, in my head, that's what I imagine, a ball falling through the air, because it carries with it kinetic energy. And I like the math and physics side, like, more. But when we talk about human beings, I certainly think about the nerve impulses and signals in the form of electricity. But there's a lot of different type of energy that we deal with. So, when we look at this, how things get energy obviously varies. Some things eat things. Some things don't, and that's a pretty big distinction. So, remind me, vocab people, our first section are going to be talking about things that make their own energy without consuming other stuff. What are those called? So, they're organisms that produce energy without consuming other organisms. We have autotrophs. Okay, autotroph. Okay. Autotrophs will wind up being at the very, very bottom of these complex diagrams that we're going to use to make sense of ecosystems, but they're there. Autotrophs collect energy from two different places. Energy from, can you give me a living thing that doesn't eat other living things typically? You say a giraffe? So careful, what does a giraffe eat? Is grass living?
Yeah. Wait, oh.
Mm-hmm.
Plants.
Ooh, plants typically don't eat other plants.
Yeah.
How do they get their energy?
Sunlight.
Oh my, sunlight. So if we have energy from light, or the sunlight specifically, we'll just write that here. These are solar paneled, they have their own little solar panels, right? Energy from sunlight, or, and this one's kind of unique and it can be an issue to come up with this. We can get energy from sunlight or other inorganic, which means just not organic, sources. Now, some of these are fairly recent and you maybe not have even heard of them. There is life at the bottom of the ocean. There are plants that exist, and plant-like things rather, that exist in places of the ocean where sunlight doesn't get to. They don't eat other stuff, but they have to get their energy from somewhere, right? Now, the whole process of photosynthesis, I guarantee we'll go through this, but just to make sure that we have it, what's photosynthesis?
Blood, sunlight, and water.
So sunlight and water, there's more pieces to it that you may be unaware of, and that's okay. Sunlight is collected by plants, right? Now, plants don't have lungs like we do, but they certainly have stomata that allows gases in and out. Do they breathe?
Yes.
They do, in differing levels, right? They don't breathe through lungs, so don't just think of it necessarily as air, because seaweed can't breathe air, but it certainly has to get breath, quote unquote, from somewhere. Now, trees, forest plants do a fantastic job of taking our waste air and making it into their waste air, and we have this beautiful symbiotic relationship. What do plants breathe in? CO2. They don't breathe in oxygen. They breathe in CO2. What do they breathe out? Oxygen. That is exactly opposite from what we do, which is awesome. That's a beautiful, nice, handy symbiotic relationship. We benefit, they benefit, everybody benefits. Now, as we go through here, I don't know how much plant biology you guys have covered. Do you know any parts of a plant? Okay, so the stem, certainly. The leaves, the roots, the bud, those are all different parts of a plant. Now, as we're going through here, what color are most plants?
Green.
Why? Ooh, I don't know. I like that idea. Maybe. I don't know. Depends. Maybe they want to be the easiest color, like bright flowers attract bees. Maybe there's something to that. Have you ever heard the word chlorophyll?
Oh, yeah.
Okay, chlorophyll, and again, we will certainly go into our botany stuff. Chlorophyll is really important. And whether you have plants that grow on land and get sunlight, or you have plants and stuff that grows way down deep, they're going to fulfill the same purpose. Chlorophyll is important. Now, chlorophyll, and let me double check the spelling. CHLOROPHYLL. Chlorophyll. Now, in our outside world, like where we live, obviously we're inside right now, but above the sea where we get sunlight, chlorophyll plays a huge role in photosynthesis. So, with light, we get photosynthesis. What does photo typically indicate? Picture, maybe. Imagine that we're taking a picture, old school. I'm going to have it set up on this, right? And I'm going to pick up this big thing and I'll hold it up so that right before I do it, I'm going to go, psst. What am I going to do?
It's gonna flash.
It's going to flash. Now, old school ones, like, and even nowadays, you get big fancy ones that people will hold. Old school ones were just like a little explosion that was contained because you needed to make light. What's light? I would say it can count as energy. It's radiation. I think we made that claim yesterday. Photons is how light travels. Light travels as a photon. So does every other sort of radiation. But when you see photo, it typically is dealing with light, not just the photograph itself. And synthesis, if you synthesize something, it's what? Creating. So you're creating. It could be an idea, it could be energy. When you see photosynthesis, you're creating or synthesizing from light. From that photons. Okay. Photo will be Greek. Yep. Okay. Now, with this, realistically, photosynthesis, you guys were right. It uses light. It uses this compound, H2O, two hydrogen and oxygen. You stick them together, you have water. Okay. And CO2. You take one carbon, C, and two oxygens and stick them together and you get CO2, carbon dioxide. Now, it's crazy, and I'll see if I can find it when we have some downtime. If you look at pictures like time lapses, you can literally see big rainforests breathing. You see dirty air come in, and then you see them expand and push out clean air. And it looks like the whole planet breathes because they do. They're a big structure that's taking all this CO2, and they're pumping out oxygen and cleaning the air. Yeah, I'll find one, for sure. Yep. Okay, now, from this, the other situation, though, and this one's going to be, we're just going to have to talk about it. There are plants that don't get access to light. We've talked at the very bottom of our ocean, miles down, it's real dark, it's real deep, it's real cold, but there are places where really hot water and other elements come out, like these big thermal vents. Now, around those areas, you're going to find autotrophs from time to time that seemingly magically, and it's crazy that it works, they will take compounds like dihydrogen sulfide and CO2 that spit out of these big vents underneath our oceans, and they transform this. They absorb these just pure chemical substances, and they transform to energy. And specifically, I'm going to say energetic molecules. Nope, I lied. We'll just say energy. So instead of going through the whole process of taking in all this stuff through light, and like plants normally do, they can actually take it and use whatever it is as hydrogen and sulfur to turn it into energy themselves. Now, the origins of life is always a big question. In the early days, the current theory, not a fact, but the proposed idea that's fairly supported, never been able to be recreated yet, so who knows, was that in the early days on the planet before there was life, there could have been a lot of these things that existed, all these different elements. And then if you add a bunch of energy, like a lightning strike or something like that, and conditions are just perfect, you get stuff to stick together, and now maybe all of a sudden you start getting proteins and things like that, that maybe under certain circumstances, these proteins stick together, and boom, you have DNA, and who knows the real like start of reproduction stuff and all that. It's a crazy thing to think about, but it happens.
How much about that?
Yep, I'm trying to think, primordial stew or primordial soup.
Yeah.
It's crazy. Question? No? Okay. All right. Now, these things, realistically, we're looking at two different ideas. Plants, which are what you and I like think about, probably grass and all that stuff outside. But you have big amounts of plants that just float around the ocean. Do you eat the mussels or clams that grow here? Why?
As harmful pesticides.
So not pesticides. It's not worried about pesticides. You run the risk, not all the time, you should not pick and eat mussels here without testing them, but you run the risk of getting PSP, paralytic shellfish poisoning. Now, if you ever see somebody eat a mussel and they start complaining that their lips are numb and stuff, you need to get them to the clinic or a doctor as fast as possible, because paralytic shellfish poisoning will paralyze their body for the next 8 to 12 hours. Meaning that if you're paralyzed, this diaphragm that runs across my body can't go up and down to pull air into my lungs, and you need a breathing machine or somebody to pump a bag or mouth to mouth for 8 to 12 hours to make sure that they get enough air. Now, the PSP isn't because of pesticides here. Instead, you'll get these big blooms of oceanic plants that grow and maybe grow down deep where we don't necessarily need the light. Plants, when I think about them, grow above water, like trees, all that stuff. Those are all plants. What do you call the big, not seaweed necessarily, like kelp and that? What do you call like the green stuff that floats around the ocean? Or red is what causes PSP. It's called a red tide. And you've probably seen this word.
Yeah.
Algae or algae, right? Okay, the red tide is a type of red algae that has terrible effects on humans, and we get PSP. A few years ago, there was a big pod of whales, of killer whales that washed up dead on the shores of southeast Alaska. And it came out to be that what happened was they were hunting in a region that was like really, really full of this algae that had PSP, and they wound up all getting PSP, and they couldn't get to the clinic because they're whales, so they all died. Okay, now plants and algae, super important, super duper duper important. I'm going to show you guys that you've been lied to, not in a mean way. What do we use for energy primarily as human beings? Like food. So let's think bigger. On an industrial scale, what powers our planes, our cars, our electricity? Most of it. Fuel. What's that fuel made of? Could be made of diesel, could be made of gasoline. On this island it's diesel, right? But my car runs on gasoline. Power plants often run on coal, but like oil is the big one. Like crude oil, and then it gets made into whatever it is. Where does that come from?
Underground.
Okay, underground, sure. Where did that come from? How did it get underground? Why is it underground? Fire, maybe?
The soil.
The soil? Why would soil have oil in it?
When I see like the American
Bam Bam, I like what he said. If you didn't hear him, say it louder, Bam Bam. Fossils.
Oh yeah, fossil energy.
Animals die, right? And they're made of carbon. And if you put carbon together into really specific chains and structures, it makes oil. And all of a sudden, we get that. Now, have you guys ever heard that's like the dinosaurs and stuff that we use? That's not true.
Wait, what?
That is not true. The very few dinosaur fossils that we have are found in sedimentary rock, which won't have oil because it's porous in structure. We don't get our oil from dead dinosaurs. Almost none of it. I would say, not confidently, but I would say 0% essentially. However, life has been around on this planet for a long time. Dinosaurs came, dinosaurs went, right? Who was around the whole time that dinosaurs were? What life that's still around today? Sharks. So sharks have been around for a long time. They did not perish. Sharks are essentially the same today as they were 100 million years ago. Megalodons are gone. What was yours? Plants. Now, plants obviously died, and if we had a huge asteroid hit the Earth and all of a sudden we have really cold because all that debris gets up in the air and now we don't get much sunlight, all the plants die. All the animals die in turn, but there's way more plants than there are animals. Way, way, way more. Now, with that, there's way more algae in the ocean than there are plants on land. Most of our oil comes from this algae being left over. It's all these plants, and specifically oceanic plants, that wound up dying and getting sent down to the bottom and compressed over millions and millions of years. Yo.
Is it real like the soil that has oil?
Kind of. So, yes, it's typically called shale. You can drill for oil in a variety of different ways. Sometimes what happens is you'll have the land, and then you'll have a bunch of rock, right? And then underground, what will happen is in one particular location, there was like a ton of algae or something that happened, and you get a big oil well. So this is one way, and this is where a lot of oil is found, like around the world. And then they go, hey, check this out. We have this big fancy invention. We're going to drill down, we're going to hook a pipe up, and we're going to pump it out. That's how we get a lot of oil. However, there are shale oil deposits. It's harder to get to, but within rocks. Not so much the soil, but what is soil but a bunch of tiny rocks, where within the rock itself there's oil. So they collect all this rock, they crush that rock, they run it through a chemical process to remove the oil from it. Way less efficient. Way less efficient. Big pits in Canada, they use a lot of shale oil production. Anyway, as we're going through here, last important part. Autotrophs, our plants and algae, these are the foundations. Plants and algae and our autotrophs are the foundations of all ecosystems. And we'll make more sense of that as we go. Okay. Now, auto, alone, independently, right, without having anything else. You think of a self-driving car, it's automatic. You don't have to do anything. An automatic vehicle, you don't have to deal with the clutch and stuff. You do it yourself, like the car does it automatically. Okay. In contrast with being by yourself, maybe you have to work with others, right? And preferably others in this situation of different species and different organisms and stuff like that. So hetero, meaning other. If we have autotrophs, we must also have heterotrophs. Now, heterotrophs. Same idea here. We'll talk about troph as in trophic or trophic levels. But when we're looking at these, if autotrophs get energy from themselves and only sunlight and inorganic tissue, or not tissue, that's not the right word, inorganic sources, heterotrophs, in contrast, then get energy from what?
From other organisms.
Energy from other organisms. Okay, now there's an easy way to think about this, and a single word that works. I'm not sure if your book uses it just as you're reading, and you guys probably didn't read the whole section, and I hope you didn't. Did you? I shouldn't have said I hope you didn't. I would guess you didn't. Easy way to word this. Eating something is called consuming. We have consumers. Now, we'll see the words primary, meaning first, secondary, meaning second. You know the word for third? Tertiary. You're close. Tertiary. Similar thing, just a fun little language thing. If you do something a single time, you've done it once. What if I do something 2 times?
You've done it once.
What? Twice. What did you say?
You've done it once.
Once again, you're right. So, yeah, I can see that. What if you do something 3 times? Not once, not twice, but thrice is the word. Okay, I didn't know if you guys knew that. I learned that when I was probably your age because a band that I liked was called Thrice. Okay. These come in a lot of flavors. And I'm going to use the word flavors specifically because we do eat a lot of heterotrophs, just for the record. Oh, yeah, we do. We're heterotrophs as well. We shouldn't eat ourselves, but all right, check it out. A few of these. I'm going to organize these. I think they'll all fit like section, section, section. I'm going to do like 4 of them on the same screen here, and I'll switch colors every time. Green makes sense for this one. We have things like cows. What do cows eat?
Hay.
Grass, hay, corn. A lot of corn in our country, realistically. Would a cow eat a chicken? Probably not. So they only eat grass and plants, right? What are they called? Herbivores. Why did I use green? Yeah, plants are green. That kind of adds up. These guys eat plants. And only plants. Okay, couple examples. Give me a herbivore. We already talked about one.
Rabbit.
Rabbit. Ooh, that's a good one.
Deers.
Rabbit, deer. So deer are weird. Deer will eat meat from time to time, given the opportunity. They're sneaky, but we'll count them. Most of the time they don't.
Just like
Cow.
pigs.
Pigs, I'd be apprehensive about it. Now, you guys are all thinking big ones. We grow a lot of crops in this country. We don't have to worry a ton. Like, people worry about deer eating their crops. Cows, typically, we don't worry about eating our crops because we keep them separate. Who else destroys crops, though?
Pests.
Pests. Give me a pest that eats plants. Ants, leaf cutters. Absolutely. Grasshoppers, locusts, all of those things. I'm going to list grasshopper because we have them. Don't forget, when we're looking at these herbivores, I often think of the big boys, like elephants and all that stuff is what my mind goes to. But there's a whole smaller world that we got to consider. Okay, lots of insects wind up being herbivores. All right, in contrast, you're probably not going to find some animals like lions and things like that eat a ton of plants, or realistically any, but there's a little thing. Wolves will eat grass. Dogs eat grass. You've probably seen a dog eat grass. It's weird. I don't know why they do it. It usually makes mine throw up all over my house. I don't know why they do it. But what do you call something that eats only meat? And I'm going to use red because carnivore. Carne. Yeah, right? Okay, carnivores. These guys eat meat. So more specifically, we can say that eat meat. And I'm going to say it live meat, which there's a weird little piece that we want to distinguish there. Lions are awful. They will literally start eating something before it dies. We don't do that so much. Maybe you've been somewhere in the world where people do eat things at that time. So people don't typically eat octopus while it's still alive. If you've ever seen the one where they pour the soy sauce on it and it does that crazy thing, it's not alive. They're making it do that. Instead of just saying eat live meat, just as an alternative, these are animals, they prey. Specifically, they prey on others. Now, oftentimes, and more often than not, the prey for a carnivore is a different herbivore of some type. But it doesn't have to be an herbivore. I can imagine a situation where a lion, hypothetically, could eat a smaller jackal or a hyena. Like, they will, and a hyena is not an herbivore, but they prey on others. Now, give me an example of some of these. Tigers, okay, so big cats. I'll just write tigers. I'm not going to write lions and stuff as well. Give me another one. Are bears carnivores?
Yeah. They're like both. Yeah.
They eat both. Cheetahs, so I'm not going to list another big plant, but you're right. They would be carnivore. A wolf. Ooh, yep, that's where I'm going to. Smaller things. Worms don't eat other worms.
They eat soil.
Kind of. We'll get there.
There's this one little guy that eats. I'm not sure what.
What do mosquitoes eat?
Blood.
So that's a weird thing. They're preying on others, right? They're not actually eating our meat, but mosquitoes certainly rely on other live animals, and they consume from those live animals to sustain themselves. I guarantee there's more insects that do this. Fleas, ticks, all those like terrible ones that we all know and hate, I imagine. Mites that live on us, they will eat not just us though.
Or the house ones.
Like bed bugs?
It's the one that live in houses, like they're very harmful. They're termites?
Termites?
Oh, yeah, termites.
So they eat wood. They'll be herbivores.
Wait, isn't it like a worm that goes through your body?
There's lots of worms. Most of amoeba. Like 75% of life on this planet are worms. Like, not in the same sense as always. Real quick, I'm not good with colors. Green and red make what color?
Purple.
Is that true?
No.
I don't know. We're gonna check. Green and red. Anybody know what color this makes? We're gonna smudge them together and figure it out.
I feel like they're gonna be yellow.
Okay, that didn't work very well. We're gonna try this again. We're gonna drop water on it. Nope, that's not gonna work. Okay, we're just gonna say it's purple, even though I know it's not purple. I have no idea what color green and red make. But we do have other types of animals. Herbivores eat only plant. Carnivores eat only meat or prey on others. What do you call someone that eats both? Omnivores.
We're on.
We are omnivores. Again, Jade, sir, if you need to go to drink, feel free, okay? Omnivore. Omni. Don't know what that root word means just on its own. All including, I think of omnipotent. Like, regardless of your religion, if there is a singular or plural god or gods, they're typically omnipotent. All-knowing, not always good, depends on the religion and belief system. But here we go, omnivores. What do they eat? Plant and organisms. If I haven't explicitly stated it, just so you guys know, you'll see the symbol over and over. This is my and symbol right here. And. I don't like the ampersand, this thing, because it looks like an S to me, and I can't draw it. I don't like this, because it's clunky to draw.
Yeah, that's fine.
Okay. Yep, and you can use it. Like, I don't mind what you use, just so you know it's not plus. I will be very, very clear if it needs to be a plus sign. All right. Plants and organisms. Give me an example.
Us, humans.
Us, human. Okay. Most of us. Some humans are herbivores, which means, what would you call a person that's an herbivore? Vegan, realistically. And there's a weird little middle spot. Humans should not, like, we're not supposed to be herbivores, just for the record. We need animal stuff. We're not supposed to be vegan, because it'd not be vegan if you drink milk, and every baby needs milk to live. Or formula, but that's it. Anyway. All right, give me another one. Bears. Cool. All right, these are the three primary ones, right? Now, looking back at stuff, there's a couple more that we're going to look at, and they could split into like specific categories, and we could go more classifications than we're going to today. If you think of something, a dead animal, what color am I using?
Black.
Okay. I'd say like black, brown, I don't know. We'll use like that color. Looks like maybe it's rotting a little bit because dead tissue. I don't know. Depends on the animal, right? Okay. Worms eat what? They don't actually eat the soil.
Like dead animals, like
Dead animals, right?
Well, no, that's the ants.
So ants will also eat little fragments of dead animals. What are you stuck on that's funny? You've been smiling for like the last 3 minutes, and I know you don't have your, I don't think, do you have your phone?
Yeah.
What number are you?
Number 2. 5. I'm number 2.
Okay.
Who's number 2? Oh shit.
I didn't even check. I don't think you're on your phone. Okay. No, you're good. I haven't seen you on it. What are you smiling about, though?
It's like holding his pencil.
He always does that in the shirt too.
I have something on my face? Okay. If it's a funny joke, feel free to share it, as long as it's appropriate. All right. So some things eat fragments of dead stuff, right? Like, they physically eat it. Vultures are notorious for doing this. There are some really sad pictures out there that have won some prizes showing just how, like, crazy vultures are. We're going to fancy word. Detritivore.
Did vultures evolve from bald eagles?
So there is an issue with that statement. And we'll talk about it here once I write this. D-E-T-R-I-T, detrit. I for I, and vores, V-O-R-E-S. Vor meaning to eat, right? Like a voracious appetite means you're going to eat a lot. A detritivore. These guys are going to eat fragments of dead matter for energy. Fragments of dead matter is their diet.
So, a black hole is.
So I would be careful. I would not say bless you. I will say bless you. But I would not say that a black hole is a detritivore because a black hole isn't alive. these things are all alive in at least one sense. So when I think of this, they eat fragments of dead matter. Worms, this is what they really eat. Soil and dirt are different. What's the difference?
Has like life issues. I don't know.
Nutrients, I think, is what Zed said. Soil grows plants, right? And plants don't grow in dirt. They grow in soil. Now, that's a subtle distinction, but I think vultures here right off the bat. And we may have to like cross over a little bit, because if you give a vulture something that's still alive but it's almost dead, it's probably going to go for it still. It might happen. Vultures are an example of that. Worms are eating the soil and the nutrients and the dead stuff that's left in the soil. That's what worms typically eat. Earthworms specifically. You said, are we what?
Are we eat dead animals? We eat dead animals.
So, in a way, you could classify us, and that's where it gets a little bit gray, right? We're not necessarily thinking of animals that have been dead and preserved, but you could certainly, with this definition, you could fit us there too. Okay. Now, you made a comment a second ago. Did these vultures evolve from eagles? There's a huge issue with that, and just don't care about your personal beliefs, but who has heard of evolution and said, you've heard somebody argue against evolution and say, I didn't come from monkeys? You ever heard that? Somebody make that argument? No, like for sure, you did not come from monkeys. Definitely not. Monkeys are around today, right? We're around today. Like, we couldn't have come from them. We're alive at the same time. We came from something in common, and then we diverged. We split. So, same way, eagles and vultures, they're both birds. They're certainly related. They came from a similar place, but they didn't evolve. Like, it doesn't happen that way. Does that make sense?
They're two separate animals.
Two separate animals that have a common ancestor. Yeah. So there is a common bird ancestor between them at some point. Okay. One more. And we're just going to go through history here. We, as human beings, have been around for how long? And that's kind of a vague question. A couple million years ago, there were human-like things that were probably smarter than regular wild animals because they started to communicate and things like that. But we weren't around much before that. We had a bunch of great primates before that eventually one of them just learned to stand up and started grunting to talk about stuff, and all of a sudden, here we are today. What came before them? Like, mammals and all that were still alive because very few of them went underground when the last big mass extinction happened. The Gulf of Mexico is where the last big asteroid hit our planet. I'm trying to think of the name of it. Can't remember off the top of my head. So before humans and stuff, who was there? Dinosaurs. Like, did they exist at the same time? No, cavemen couldn't hunt dinosaurs. They were millions and millions and millions of years apart. Okay, so the dinosaurs existed. Now, dinosaurs, when you think of where a dinosaur lived, what's the landscape? Ooh, so maybe tundra. Sure, Pangea. Love hearing that. I think of like a rainforest because I think of Jurassic Park. Yeah, somewhere in there. Now, that means, just check this out, lots of dinosaurs were carnivores. Could dinosaurs be herbivores? Yeah, because there were plants back then. There's plants today. Were there plants before the dinosaurs?
Probably, yeah.
Yes. Now, at some point, because life eventually had to start somewhere, there must have been no plants. Do you know what came before plants?
Oh yeah. I watch Minions. Those little things.
I don't know what that is. I've seen it, but I don't watch it closely. Okay. So, I'll tell you, a long, long time ago, before we had plants, we did have other things. Last little piece we're going to hit is decomposers. And these have been around for so long. We are more closely related to some of these than many other things, and it's bizarre. Do you guys ever heard somebody use, do you guys like to cook? Anybody in here? Have you ever heard the phrase umami?
Oh, yeah.
Okay, what's umami? And I know how I would describe it, but I actually don't know the definition, so we're going to Google it. Yep, it makes me think of that commercial from years ago. So umami, U-M-A-M-I. I think of Japanese food specifically, just before I read it, because I think of really good ramen broth is probably going to have some sort of umami essence in it. So umami, hey, MSG, cool. One of the 5 basic tastes. We know what sweet is, we know what sour is, we know what salty is, We know what bitter is, and umami is just like savory. Now, this is what I think of. I think of meaty flavor. If you are, for whatever reason, what is going on, Fred? You keep laughing.
There it is, and then he's
What is it? Are we passing notes? Something? Something happened that kicked it off. What? I don't need to know your exact thought process. What started it?
I don't know, it's like
What?
I don't know, I just keep laughing. I don't know. See?
Okay, if it's something on my face or something, tell me before you leave. Like, just in case. Am I fly down? No? Alright. Okay, here we go. Decomposers. Lost my train of thought there. Sorry, I'm going to keep calling you out, just for the record. Just in a good mood because he's listening to me talk. When you think of decomposing stuff, imagine, if you will, a dead tree in the middle of the forest. What might you find on that tree? You might find life of other types, right? Maybe there's insects. But there's other life around. We see similar life growing here. We get a lot of moss and lichen and things like that. What grows amongst the moss and the lichen? Especially right now, if you go out into the tundra, you'll see them. Ground squirrels eat them. Mushrooms. Mushrooms are what I think of as umami. If you're a vegetarian or vegan, or there's some diseases where you just can't eat meat because it gives you allergic reactions, it'd be a terrible disease for me to have because I enjoy red meat. But if you don't eat meat and you don't want to eat like soy burgers or whatever, what will they give you? That often has a meaty texture. Mushrooms. Decomposers have been around for a long, long time. Before we had forests full of trees, we had forests full of gigantic mushrooms. Like, they existed. So, for this, decomposers. You guys have all seen a mushroom. That's the easiest one to think of. What's a mushroom's mouth look like? Nope, it doesn't, right? Like, it doesn't even make sense because mushrooms don't have meat. Or mouths, sorry. So, they have to do this somehow, right? They have to get energy from something. Mushrooms are not plants. They do not photosynthesize. They can grow in the dark. In fact, they prefer the dark. As you're looking at that, decomposers of many different types. They have specific enzymes. Which, what's an enzyme?
Is that a probiotic?
I wouldn't say it's a biotic necessarily. It could be enzymes are just specific chemical substances. So specific enzymes, we have enzymes in our gut that break down food. We call it stomach acid. You have enzymes in your mouth that also help the digestive process. So enzymes break down matter.
Spit that comes out of the bottom of the tongue. Like that. Like when you have food in your mouth and it's like...
What? Hit it again. I didn't catch the first part.
Like when it's the food's in your mouth and then like the saliva from the tongue is like there's like holes.
Okay.
It's like a, I think it's a part of the mouth process.
Elaborate.
Cool. So I think of fungi or fungi when we're looking at this. Now, couple things that are just interesting. We talk about enzymes. Anybody here like pineapple?
Yeah.
Pineapple is easily my favorite fruit. If you've ever sat in front of like a fresh pineapple and you started eating and eating and
Oh,
eating
yeah.
because it's so delicious, what's your mouth feel like after a little while?
It's like kinda itchy and it's like
Your tongue starts to hurt. Your
Yeah.
mouth starts to hurt if you eat a ton of fresh pineapple because there are enzymes within pineapple that's done to try to deter that from happening. They have acids that will start literally breaking down your mouth and like it's kind of eating you back, although it's not doing it for the purpose of life. Now, of all these types, you asked at the beginning of class if I would show that video. Tomorrow we're going to finish this section, just so you're aware, and I believe we finished the chapter, but I'll double check on that. We're going to start looking at food chains and food webs tomorrow, which you guys, I imagine, have seen those things in your science classes historically.